Hey, welcome back to Math with Patrick. Today is March 29th, and we have problem number 88 from this Daily Epsilon calendar to solve together. And just like every other problem, the answer is just going to be today's date, which is 29. We need to show for what value of x does 1 plus 1 over x to the power of x equal 1 minus a 30th to the power of negative 29. So here's a few things that I'm thinking of right now. First, it might be useful to try to figure out a better form of writing this number. My other idea is sometimes when you're working with fractions, trying to find a common denominator is a good strategy. And lastly, I'm also thinking that whenever you're working with exponents, sometimes it's nice to match the base. So let's try those three things in that order. Thing number one is let's see if we can rewrite that left number to be something a bit easier to deal with. And I guess my first step is kind of tying in with that common denominator idea. So 1 would just be the same as 30 over 30. And now that I have a common denominator, I can subtract the two fractions from each other. So if you have 30 thirtieths and you take away 1 of the 30ths, you're going to be left with 29 thirtieths. And now let's deal with that negative exponent. In some sense, negative exponents mean division, and I'll show you what I mean. If you count by your powers of 2, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, that's going to be 2, 4, 8, and then 16. And essentially, as you work your way up this list, you're just multiplying by 2 every time. So if you wanted to work down your list, you could divide by 2. So following this pattern, 2 to the power of 0 would be 1. And then 2 to the power of negative 1 is going to be 1/2. And so in some sense, negative exponents are division. And in another sense, you can get rid of these negative exponents as long as you just kind of flip your fraction. So here, I'll actually show you what I mean. 2 cubed was 8. And if we continued that pattern the other way, 2 to the power of negative 3 would be 1/8. And so you can kind of see how 1 over 8 and 8 over 1, or just 8, are reciprocals or flips of each other. And the only thing that's different in the exponential expression is that there's a negative sign on one of them. So if we negate the exponent, it's the same thing as flipping the fraction. And we can do basically both steps at once. So we can flip the fraction, and that will, maybe it'll remove the negative sign, or you could think about negating the exponent, but then a negative times a negative is just a positive. So however you want to deal with it, you can get rid of that weird, tricky negative exponent by flipping the inside part. And this feels a little tedious. It's basically going to be 30 times itself 29 times on top. Oops, that's supposed to be 30. And then we're going to be dividing by 29 multiplied to itself 29 times on the bottom. So I can already tell that this number is going to be a little bit more than 1, because each of these numbers are a bit more than 1. So if you keep multiplying numbers a bit more than 1, we're going to keep increasing the number. But I'm not sure exactly how big that's going to be. So at least that's one way to rewrite the left side. And I guess I need to try to match it to the right side. So let's try doing that thing where we're finding some kind of common denominator or combining our fractions in some way. I can do the same process over here. 1 could be written as x over x. This should be true, or this will be true, for any value of x besides 0, because 0 over 0 is a little bit weird, but something like 3 over 3 is still going to be 1. So as long as x isn't 0, I'm fine. Oh, and then there's still power of x. And I could combine them under or with the same denominator. The x plus 1 will combine on the top. And I'm just trying to figure out if there is some value of x that matches the value here that I got earlier. And it seems like there is. It looks like I'm allowed to slot in a 29 in the denominator, a 29 in the exponent, and then a 29 for that value of x in the numerator. And everything just kind of stays exactly the same, including that plus 1 that's still right here. And you can see how the numerators match. That's a 30 and a 30. The denominators match and the exponents match, and they're just both 29s. And so since the left side of my equation matches the right side of my equation, I know that x is equal to 29. And that's today's date. So we're basically all done. This problem is a little bit weird just because we didn't really solve for x in a conventional way. I was only able to almost luckily match it up with the left-hand side expression. But there are some useful tools along the way. So if you encounter a problem like this, you could try combining your fractions together. You could try removing any unnecessary negative exponents. And you could try maybe matching that base with each other. That 30 over 29 matches with this 30 over 29. So maybe you have a different way of solving it, but this is the one that I was able to find first. And now you can see that x is 29. So thanks again for coming along. As always, I'll see you tomorrow. Bye.